Welcome. Just like what I've said from the previous lesson, this video is about solving linear equation using Gauss-Jordan reduction method. If you recall from the previous lesson, we talked about Gaussian elimination method that uses REF and back substitution to solve for the linear equation. In Gauss-Jordan reduction method, we will only use the RREF form and no back substitution needed because the values for the variables of the given equation will be solved in reduced row echelon form. Now that you already have an idea of what we will do, we can proceed in the examples. Example number 1. Convert the given linear equation to augmented matrix. Using the type 1 of elementary operation, interchange R1 and R4. Change the first entry of R2, R3, and R4 to 0. For R2, multiply -1 to R1, then add to R2, R3 to -2 R1 plus R3, and R4 to -2 R1 plus R4. Multiply R2 by 1 over 2 to change 2 and become 1. After that, multiply R2 by -5, then add to R4 to change the second entry of R4 to 0. Next step, by multiplying 1 over 3 to R3, will change its first non-zero entry to 1. Turn the third entry of R4 to 0, multiply R3 by -17 over 2, and add to R4. The first non-zero entry of R4 is negative 8. Multiply negative 1 over 8 to R4 to change it to 1. The augmented is already in REF form, but we're using Gauss-Jordan reduction form, so we will continue transforming the augmented matrix to our REF. Change the second entry of R1 by adding R2 and R1. After that, turn the third entry of R1 and R2 into 0. Multiply R3 by 5 over 2, then add to R1. For R2, multiply 3 over 2 to R3 and add to R2. Change the fourth entry of R1, R2, and R3 to 0. Multiply R4 by negative 3 and add R1. For R2, multiply R4 by negative 2, then add to R2. And for R3, multiply negative 2 to R4, then add to R3. We already transformed the augmented matrix to RREF. Now, we will rewrite the augmented matrix to linear equation to see what are the values of the variables within the equation. To finalize our answer, the solution for the given linear equation is 1 over 4, 1 over 2, 1 over 2, and 1 over 4. To check if our solution is correct, substitute the values of the variables in any of the given linear equation. Example number 2. Convert the given linear equation to augmented matrix. The first non-zero entry of R1 is already 1. Multiply R1 by 2, then add to R2 so that first non-zero entry of R2 will be 0. And for the R3, multiply -4 to R1 and add R3. The first non-zero entry of R3 is already 1, but negative. So we will multiply R3 by -1 and interchange the position of R2 and R3. Now, turn the second entry of R1 and R3 to 0. Multiply R2 by -1 and add to R1. Multiply -2 to R2 and add to R3. If you notice, all the entry of R3 is 0, so we will not have exact value for the variable z. If we will rewrite augmented matrix to linear equation, we will have x plus 0y minus 3z equals 0. 0x plus y plus 2z equals 0. 0x plus 0y plus 0z equals to 0. Because we can't determine the value of z, we will solve for the values of x and y in terms of z. Therefore, the solution of the linear equation is 3z, -2z, and z, where z is any real number. And that's it. We already discussed how to solve linear equation using Gauss-Jordan reduction method. I'm hoping that you understand the procedure in solving linear equation. Just always remember to double check the steps that you are doing while solving. And when you get the solution for the linear equation, check your answer by substituting the values of the variables in any of the given equation. When the equation is equal, it means that your answer is correct. To be more confident with your answer, try to substitute all the given equation. Until the next discussion, bye!